Hello, everybody. Today I'm going to be talking about electronic manufacturing. I'm going to be talking about specifically printed circuit boards. I'm going to go over some of the chemical safety with them and some of the ability to control some of the hazardous chemicals that we're exposed to. Here are some references to start us off. I am going to be mentioning some of these references throughout the entire presentation. I did stick some of these in there for FYI, some really awesome YouTube videos to show what the industry leaders are doing for PCB manufacturing. And so take a look at these. The ones I don't reference, go back and revisit them. So the goals of the presentation, I'm trying to describe the processes and steps of PCB manufacturing. We're also going to understand the chemical hazards in PCB manufacturing. Those two bullets are really important because I'm going to marry those two together. So that way, as we're talking about the processes, we're also going to be talking about the hazards. Number three there is learn about the hazardous chemicals that we're going to focus on. So there are hundreds of chemicals, but I am going to try to focus on two of them. That way we can look at the ones that are most federally regulated and the ones that are kind of the most exposure that we're going to get through the entire manufacturing process. Number four is I'm going to be exploring those exposure limits for the focus chemicals. I'm going to be reviewing regulatory standards for the focus chemicals, and I'm going to be identifying control measures for those hazardous chemicals. So what is a PCB? A PCB is a structure for assembling electronic components and their connections into a unified circuit that allows electrical currents to pass between those components. Anything you could imagine that's electronic, TVs, smartphones, radios, they have these PCBs that allows for communication functionality to happen, to allow that device to do what it's supposed to do. So what are the steps in PCB manufacturing? Number one is preparing the design files. Number two is preparing the raw materials. Number three is performing the PCB fabrication of printing, the inner layer, and graphic etching. Now, number three is important, and I just kind of want to reiterate here that graphic etching, this is what I thought at first, was it's not some hard point where we're etching our name into something. No, this is usually done with solvents, some type of heavy solvents that are washing away layers of heavy metals or else other polymers in order to get the intricate designs that you see on PCBs. Number four is drilling holes and plate them to connect to different circuit layers. Number five is applying the soldering mask and silk screen printing. Number six, this one's really important too, is apply surface finishing and assemble. And that surface finishing, believe it or not, is usually solvents. And solvents are they're almost in every single step here, but in 3 and 6 they're huge. Number seven, completing the PCB assembly by soldering components onto the board. And here's where we get to some of the heavy metal stuff that we'll be talking about too. So common chemical hazards in PCB manufacturing, there's tons, hundreds. Chemicals being used at every step. That's how we get the ability to have these intricate designs with the copper filaments and the different diodes and all of our intricate parts of that PCB. But the chemicals that go into there are volatile organic compounds, acids and bases, usually sulfuric acid and ammonium persulfate, organic solvents, and I keep saying solvents, and I'm going to keep saying solvents, but the ones that I am kind of looking at is acetone and methyl ethyl ketone, but there were dozens of solvents that were used in every single part of the process, and then heavy metals. So cadmium and lead being two of the heavy metals that keep coming up in some of the research. So chemical hazards of focus in PCB manufacturing. So I'm going to be looking at acetone. And the reason why I'm looking at acetone is it can be used in multiple steps, but it's used in steps 3 and 6, just like I was talking about, whenever we're etching and also whenever we're finishing. And then lead, it's a heavy metal, are used in mostly for conductive purposes and are present throughout most of the processes. Exposure to the lead and other heavy metals occurs during step 7 in the soldering process. And below I kind of attached, we have a picture of chemical formula of acetone and some of the hazardous pictograms. And I have a PCB board here with some of the metal diodes, and you can see kind of as we start to solder some of those, we can get some of those fumes generated and get some of the exposures that I was talking about. So exposure limits for acetone and lead. So in here I put the CDC NIOSH pocket guide, and we'll go ahead and follow those links. But I wanted to kind of really touch base here on the REL being 250 parts per million. The PEL for acetone is 1,000 parts per million. Common route of exposure is inhalation due to high vapor pressure, and acetone can be absorbed through the skin as well. So if we click and follow this link here, and you can see everything that I was talking about, our exposure limits, chemical formula, and then there's that high vapor pressure, 180 millimeters per mercury. Same thing if we cruise back and we go to lead. So lead is got a NIOSH REL of 0.05 milligrams per cubic meter, and then OSHA's PEL is the same thing, 0.05 milligrams per cubic meter. A lot of the exposure comes from wastewater from the chemical processing in the etching phase, and that can lead to dermal absorption. And also inhalation hazards could happen during fumes from soldering, and it's the same thing. I included your NIOSH pocket guide here. Some of your time weighted average stuff, some of your RELs and PELs, but then also, what are your routes? And just like I was talking about skin and inhalation, and then here's some of your symptoms that you get from it. Okay, on to the next. Regulatory standards for acetone and lead. So we have really awesome table. I'll let you all click on that, but it takes you to the regulation, and it's from the NCBI bookshelf, but it's good. The only thing is acetone is really heavily regulated by OSHA and NIOSH, being a hazardous chemical. But the one I really wanted to get down to and show you all is the reason why I picked lead is because lead is regulated heavily by the federal government, and we have the EPA looking at the Toxic Substance Control Act, Clean Air Act, Clean Water Act, Safe Drinking Water Act, Resource Conservation Recovery Act. We click on this, it takes you to all of those that I just mentioned. You'll be able to take a look, follow, go down the rabbit hole as much as you want, but this is kind of the reason why I chose to pick lead to focus on today. Okay, so what are some of our exposure control measures during PCB manufacturing? We want to first focus on automation. Automation is the most effective because it's elimination. You only need to inspect the final product after each step via your computer. You don't have to be near the hazardous substances, any of the solvents, any of the potential heavy metals. Automation is the way the industry is going towards. Next number 2 and number 3 is using either lead-free soldering alternatives or less volatile solvents. Number 4 is localized ventilation for steps 3, 6, and 7. So number 4 is engineering controls. And then last here is PPE. Everyone wants to jump to BPE, but it's last. And that includes gloves, aprons, and using a papper, and making sure you have your acid cartridge filters. That's the important part with that papper. So the most important is automation. Automation, elimination, then we're doing substitution, engineering controls, and then finally PPE. I did put in here in this graphic kind of what our automation looks like to see as we're making our PCBs what it looks like at the very end. And we don't need to be present. We can actually be doing some critical control points here, some quality control points through that manufacturing process. Really quick test for you all. What chemicals doesn't belong in the list for PCB manufacturing, and what control is best for occupational exposures? That's all I have today. Thank you so much for joining me. Let me know if you have any questions, and you all have a good day.